Hey guys, what is up? It is your good buddy Sam, and it's time for another very exciting Max MSP tutorial. I can't express how sorry I am that it's been so long since the last one. It's been something like 2 months, and that is absolutely shameful. If it makes you feel any better, I've been on a sort of Euro trip. I've been going through Paris and the Netherlands, and I'm now here in my last week in Berlin, and it's very sad. And I'm trying to lift my spirits the only way I know how, with a couple hours of max hacking and a few pints of beer, which happens to be incredibly cheap in this city. So it all sort of works out. It's kind of hard to go. But anyway, let's get started. Start by opening Max. Incredibly difficult to hack around in Max if Max is not open or installed on your computer. I would say it's borderline essential that you install Max before beginning. Anyway, so what are we going to talk about this week? This week we're going to do a little bit more JIT-GL gen stuff. We're going to do some more OpenGL stuff using JIT-GL picks, and I'm going to show you I'm going to show you specifically how to do feedback. So how to do effects that store the previous frame, store the previous frame and use that frame to compute the next frame, which doesn't sound that exciting, but allows you to do some really interesting and really fun. Jesus, it looks cool, okay? So let's get started. Let's start by making a P window. I'm going to give it a name. I like to name my P windows. It's a sentimental, it's about an emotional attachment that I draw to each P window as a Max craftsman. I'm going to call this one Fluffy. After my late grandmother. And imagine though, that would be weird. Anyway, so here's my P window. It's down here in the corner where P windows belong. I'm going to throw up some boilerplate stuff here so we can get some content in there. jit.qt.grab, which will open up my MacBook Pro's little built-in camera. Presumably people can use those to watch you. They'll install viruses and then watch you without your knowing. I'd say go ahead. I can, if you really want to do something that boring. I can't even imagine how boring it is to watch me sit at this computer and work/waste time. All right, anyway, so we'll open this thing up, hook this guy up to here. There it is. There's my face there in the screen. Unbelievable. And I swear to God, as soon as I get back to the States, this is gone. I just didn't have the patience to do it in Europe. But yeah, I know it's out of control. It's hard to look at. I mean, it's hard to look at for me. I can only imagine how bad it is for you. But anyway, this is not about shaving. This is about Max. So anyway, we've got our image. The next thing that we want to do is a little bit of frame differencing. Wouldn't that be nice? So what I mean by frame differencing is I want to take this frame and subtract it from the previous frame, or the other way around. It doesn't actually matter. To do that, we're going to use jit.absdiff. Takes the absolute value of the difference between the current frame and the previous frame. And then here's a cool trick. Use a trigger with the arguments list and list, because what passes between these jitter objects is not an actual matrix, but rather just a symbol list that tells the jitter objects where to look for the matrix. And so if I throw this down here and then hook this guy up to this here and this outlet up to this inlet, this will first compute the difference between the current frame and the previous frame and then store the current frame as the previous frame. I'll hook this bitch up. And now we have this weird, flashy, glitchy light show going on, which is cool, but not exactly what we wanted. The reason this is happening is because jit.qt.grab, we're telling it to give us a new frame very, very quickly, and sometimes we're asking it to give us a new frame before a new frame is ready from the camera. When it does that, or rather when that happens, it just outputs the same frame it just output. And of course, the difference between one frame and the same frame is nothing. So if we add here the unique attribute, set that to be 1, this will make it so that jit.qt.grab will only output a frame if there is a new frame to be output. And now, this is much more what we want to look at. You can see that I'm now doing some frame differencing, and as I do this very strange dance that I'm sure is sort of nauseating to watch, you can see what the frame differencing is doing and how it emphasizes all the edges, because that of course is where the biggest difference between the current frame and the previous frame are, in the edges. biggest difference is. Anyway, so there's that. Now, the next thing that we want to do is actually get some of this stuff, well, let's do this. So you can't see it, but there's actually a lot of noise here in the background, and for our application, we're going to want a very clean image. So I'm going to add a JIT.gl object here that's going to do some thresholding. So make a new object, jit.gl.pix, and this, of course, is going to bring up the familiar gen sub-window here where we can do our pixel for pixel jitter shader manipulation stuff. So we're going to do a super simple one here, just greater than pass with the argument thresh, and then we're going to make a parameter called thresh and give it the default argument, default value rather, thresh, default value of 0.1. Hook this up to this and this up to this, and our generated code, let's see, a parameter called thresh greater than, yes, looks good, looks good. What this is going to do is let us cut out stuff that isn't be below a certain intensity. So I'll hook this up to this, and then we'll make really quickly a slider, slider, and make sure this goes between 0 and 1 by making it a float, and then setting the range to be 1. And then finally, we'll throw a message box down here that says thresh $1, so that whatever comes out of this slider is going to go into this gl.pix object, and throw this over here. And now we see nothing. I'm out of the threshold. Perfect, we broke it. The reason this broke is, of course, because this is a jit.gl.pix object. It's a jitter, it's an OpenGL object. And OpenGL objects are not like these other jitter objects. They play by different rules. They have different customs, different religion, a different way of life. And in particular, they really need a jit.gl.render object in order to do anything. They have to be explicitly rendered. So I'm going to throw this jit.gl render object over here. I'm going to make a trigger object here with the bang, and it's going to send out first an erase message and then a bang. So first it's going to tell this GL render object to erase its current context and then draw the next context, or rather draw the next frame. And it's turned this, it's turned our context gray, which is cool, but probably not what we wanted. That's because this render context is actually trying to render a scene. It's drawing into this window here a scene, and we haven't put anything in this scene. This glpix object goes ahead and makes a texture, but it doesn't actually render anything into the scene. We're going to add a jit.gl.videoplane object to do just that. Videoplane, and we'll give it some arguments. We'll give it the arguments transform reset 2. What this means is that most objects in the OpenGL world have some kind of matrix applied to them that accounts for the perspective and where the camera is, and we're telling the GL context, before you render this video plane, throw all that garbage out and just throw the stupid video plane right there in front of the screen. I'm also going to set depth enable to 0. And what this is going to do is make it so that this video plane doesn't, if there's something in front of it or behind it, it just ignores all that garbage and draws the goddamn frame. GL.pix hooked up to video plane, and now, look at that, it's working, unbelievable. And as we move this threshold up, we should see fewer and fewer and fewer pixels, and look at that, it's working. It's fucking working, man. My parents said I would never accomplish anything, and here I am alone on a Wednesday night dancing in front of my computer, so there. Anyway, that's rendering and it looks good. So, big accomplishment. Now we get to the interesting part. The interesting part is we want to now have some kind of feedback. In order to do that, we can't just keep a jitter matrix around and add it to the previous matrix like we might do if we weren't working with OpenGL. We're working with OpenGL, and so what we need to do is we need to do everything in textures. This jit.gl.pix object exports a texture that goes to this video plane, which is why we can see it here, because that texture gets mapped to this video plane. But we need to be more explicit with these textures. And the way we're going to do that is with an object called jit.gl.node. Jit.gl.node is a magical object. What it does is, in capture mode, with capture enabled, you can hook its middle outlet up to any number of OpenGL objects. And what the GL node object will do is render all those objects into a single texture and then generate a texture that you can map to other stuff. So if I take this middle outlet here and hook it up to this jit.gl.video plane, this context goes gray again. That's because the texture of this video plane is being captured by this GL node, and can't be used to render to this context anymore. So that's grabbing us the current texture, the current frame. What about the previous frame? Well, to do that, we just make another video plane object, hook the same node up to this jit.gl.video plane, hook this guy up to here, and now what we're doing, this is going to blow your mind. So now what we're doing, man, I hope this doesn't look crazy complicated. So all we're doing is taking the current frame and this frame, which is where we're storing the previous frame, merging that into one texture, and then writing it here to that previous frame, which I think is pretty slick. I'm going to move this GL node over here, move this over here. Now we don't see anything anymore, but that's because, of course, both these video planes are being captured. And like anything in life, we can solve this problem by adding yet another video plane, mapping this texture onto here. And now, yeah, look at that. We're seeing stuff. It's unbelievable, but we're seeing stuff again. Now what you're noticing is that this probably just looks like the... my starter disk is almost full. Oh my god. Jesus, I hope that's not a problem. Maybe I can delete something really quick. Yes. Does this help? This isn't something that one should be doing in the middle of a video. Okay. Anyway, so what was I saying? Okay. This is all going to be fixed with the magic of editing. So you may notice that this doesn't actually look like the two previous frames merged together. That's because we're not doing any blending. So what I want to do is render these frames in order. To do that, I can change the layer attribute of each one. If I make this one layer 2, this middle one layer 3, layer 1 rather, and this last one layer 0, oops, at layer 0. This will guarantee that OpenGL will render first this video plane, then this video plane, and then this video plane. Last but not least, I have to turn on blending. Blend enable 1. And now we have absolutely nothing, which is disappointing, I know. But that's because we haven't set the blend mode. The blend mode we need to set to be something appropriate. Let's try 3.1. Yeah, that's more like it. So what is 3.1? What we're doing in blend mode is we need to tell the graphics card how to, what is this? We need to tell the graphics card, which is a very dear friend of ours, how it should combine the source matrix, which is to say what we're adding into the render buffer, and the destination, which is what's already there. There are a whole bunch of options here that use the alpha and the color. 3 for the first argument says take the color of what you're adding and use that to determine how much of the source is added. And 1 says, and for the second argument, says add all of the destination. So in other words, when the color of the source is very bright, we're going to add it. When it's black, we're not going to add anything. And so all that we will see is the destination. Now what that means is that we're just going to be adding these lines into what's already been drawn and nothing else. So that's that, my friend. Layer 1, transform reset, cool, looking good. Last thing we want to do is throw a jit.gl.pix in here between when this texture is being rendered and when it's getting thrown into this video frame here. And that is it. The magic is complete. And look at that, oh my god. Well, that's a very silly effect that is not particularly pleasing to look at. What we want to do, this jit.gl.pix object is where we have all the power now to compute what we're going to do with the previous frame. If we come in here, the simplest thing that we might do is add some kind of feedback. So we're going to multiply by a value that I'm going to call echo. Make a new param called echo and give it a default value of 0.9. This is just saying take the previous frame, multiply it by 0.9, then add it to the next frame. If we close this, you can see what that looks like. Yeah, I think that's good. And then if I make another one of these, duplicate it, instead of calling it thresh, let's call it echo. Oh, wow, that didn't work out the way I expected, but everything's fine. Hook echo up to here, and now we can, oops, not like that, hook echo up to here, and now we can determine how much of the previous frame we want to keep around. This is up near 1, and so it's all the previous frame. This is not quite 1, but that allows me to do the amount of dancing in this video. It's so unexpected, but definitely, I think, appreciated. So this is, I think, the very basic, this is probably the proof of concept of feedback. So there you go. What we might do now, we might go into this jit.gl.pix and I'll show you another cool effect that you can do. In addition to playing around with echo like this, let's do a little resampling. So what I'm going to do is use the nearest object. What nearest does, nearest will take a position in the input matrix and sample from that, grabbing the pixel that is nearest to where you told it to sample from. So in other words, if we have this nearest object here and we say sample at 0.5, it'll grab the sample that's closest to the middle of the image and use that, send that value out of this outlet here. So we pass, we're going to make an object here called cell and an object here called dim. And we're going to use this to compute normalized coordinates. Cell is telling us for the current pixel, which row and column are we dealing with. Dim tells us the number of rows and columns. So if we divide one by the other, we'll get a number between 0 and 1, where 0 is the leftmost column and 1 is the rightmost column. 0 is the topmost pixel, I think, and the 1 is the bottommost pixel. Might be the other way around, I'm not sure. Anyway. So we're going to do this swizz operation here, swizz and swizz, which will extract from this cell the x coordinate only and the y coordinate only. I'm going to add 1 to this x coordinate and also subtract 1. And then using the vec object, rebuild a vector of these values. So if we were asked to look at column 20, row 10, this will compute column 21, row 10, and column 19, row 10. Not so complicated. I said it was not so complicated, and then I went and screwed it up. So maybe it is complicated. And then if we divide these both, or rather divide each one of these by this dim here, these will now be scaled normalized coordinates between 0 and 1. So this is saying for each pixel, look at the pixel that is immediately to the left and to the right of that pixel. That's the pixel value that will be coming out of each of these nearest objects. Then I want to compute the difference between that pixel and the current pixel. Take the absolute value of that, add these guys together, and use that as my output, like so. It doesn't look so exciting now, but we can fix that. If I set the echo all the way up, yes, that's good. Play with this threshold a little bit. In fact, I think if I set this echo to be a little bit higher than 1, just a little bit, 1.01 for example. Yep, there you go. See, so it's taking each pixel and using it, setting the neighbor of each pixel to be equal to, so for each pixel it's saying if my neighbor is bright, then make me bright. And that's why you have these pixels sort of traveling left and right across the image, which is pretty sweet, I think. And so that's it, guys. That's basically everything that I wanted to cover in this tutorial. You can see how you can use feedback to get some cool effects. And if I crank this up, let's see how crazy it gets. Yeah, this is what's up. So yet more ways to dance in front of your computer and entertain yourself. I hope you learned something interesting. I'm going to post this patch right away so you can play around with it. And yeah, greetings from Berlin, and I'm excited to be back in the States. If anybody's around in San Francisco and you want to hang out, get a coffee, and talk Macs, I would be more than excited. I would be thrilled, in fact. So anyway, thanks a lot for watching, guys, and I will see you in the next video. Well, you'll see me. I will... Anyway, goodbye.